So welcome students, we're starting a new section today and it's called Congruent Figures. And congruent figures are two geometric shapes that have exactly the same size and shape. And how one differs from the other is that one is at a certain place on the coordinate plane and the second one is at a different place. And so there's some type of displacement. And that displacement is called a rigid transformation. And the first type of rigid transformation that we're going to be talking about is what we call a translation. Okay, as we talk about a translation, there's a couple of things that we need to make sure that you understand. Where we start at, like this black figure here, is what we call a preimage. That's where we start. And that is designated by a point S in this case. There's a point S, there's a point T, there's a point Q, and there's a point R. So this is where we begin, and it's called the preimage. Where we end up is called the image. So that's the finish. And where this is called point S, this is called point S prime. And let me zoom in here for a minute so you can see where we get the prime mark from. There's a little tiny apostrophe, like an apostrophe S right here, a little tick mark on the S. That's what we mean by a prime. So when you see two figures, and let me zoom back out on this. So when you see two figures and you see S and then you see S prime, what we're trying to tell you is that we're starting at S, and the translation of the original to the new one. So here's where we start, this is where we finish. It moves right 3 places and then down 1, minus 1. So that's the rule that we're learning how to write. Now remember, it's important that all rules must work for all points. So if it works on S, it has to work on T, it has to work on Q, and it has to work on R. We've already counted it for S, 3 to the right, so x plus 3, down 1 would be y minus 1. And if we look at T, it works for T to T prime, Q to Q prime, and then R to R prime. So those rules all work. Okay, now let's go to this other one over here, and let's apply the rules that we've just learned. Okay, so we start at F, and we go to F prime. And if you look at F, it goes 1, 2, 3. So that would be x plus 3. And I would go down 1, 2, 3. Now remember to count the squares. Don't count the tick marks, or you'll end up getting the problem wrong. So we've checked it for F. Now if we check it for all the other ones, x plus 3, y minus 3, x plus 3, y minus 3. Yeah, it'll probably work for all of them. Now, one thing that I would use as a general rule, instead of trying to check all the points, which is still a good thing to do, usually if you can check 2 points and it works on 2 points, it's going to work on the other points as well. So now to write this rule, I would say the rule is in parentheses, or x comma y, and then I have an arrow notation. This is called arrow notation. And then I write how the ordered pair changes for each x and for each y of all the ordered pairs. So x would be, I add 3 to every x, and y means that I would subtract 3 from every y. So that's the rule that maps the preimage, which would be F, E, D, and G, to F prime, E prime, D prime, and G prime.